Recording in progress.
So, like I said in the previous one, you just follow the same methods that I showed you to find the mean standard deviation and variance. So now let us start the next topic, which is binomial distribution. A good example of continuous probability distribution is called binomial distribution. It's called a normal distribution, not binomial.
Excuse me, Professor.
Please mute yourself. So the normal distribution as
Excuse me, Professor.
Yep.
Please, I need the question of the last one we solved.
And that one is
Snap it.
maybe when we finish today. Now we are doing something new. Remind me when we finish today. This session will take a few minutes to end. Let me see if I can edit this. So then, before that time, before I take the attendance, I can show you, open it again. Okay. So because I've already closed it, you know, a new one. So by the time we leave, I can also upload it. I think I don't even save it. That solving, but the question is there, but the solutions I didn't save it. Really. But in any case, I'm opening it. I'll open it before we leave, and so you can see it. All right.
I couldn't see it in the video.
Yes, it is the video too.
All right.
When you watch the video, you can see it on the video too. Yes. So I think that would be the best option. I can put the video for today, and then you can go through it and see it there. Okay. All right. Normal distribution, many continuous variables like heights of adult people, adult men, cholesterol levels, and so on, have a distribution that are bell-shaped, or that are shaped like a bell. Let me put it that way. So many of the variables have distributions that have the shape of a bell, or we can say that they are normal. I think I've shown you the diagram before. They look like this. Why? If you take the heights of adult men in, let's say, 6 men and plug the histogram, it will not give you a smooth curve like this. But if you take the height of all the adult students, all the grown students, boys in Baltimore City Community College, all of them, and then plot their graph, so long as the size is large, I'm sure it's large, or even men and females, so long as they are adults, it will give you a smooth curve like this. So this kind of smooth curve we call the normal, or you can call it the bell-shaped, because it is shaped like a bell. Excuse me. You can also call it the Gaussian curve, named after the mathematician that derived the equation for it. Now, more good examples. I will give you more examples, like the blood pressure, normal blood pressure. If you take the blood pressure of all the residents of Baltimore City, it will also give you the smooth curve like this. I'm talking about those that have normal blood pressure. Some of them will be a little bit higher, some a little bit lower, but in the end, they will give you the smooth curve. Now, so the normal distribution is a continuous, let me put it this way, that's the best definition. It's a continuous, symmetric, bell-shaped distribution of a variable. So we use this to describe many variables because deviation from this norm is not really much, except if there's a problem, like somebody who is a giant, or maybe somebody who have a very have a blood pressure problem. That means the blood pressure might deviate a lot from the norm. Okay. Now let's look at examples. The normal range of the systolic blood pressure is 110 to 140 millimeter of mercury. Anybody who has something bigger than this there's a problem, or lower than this, there's a problem. We have normal interval for a person's triglycerides is from 30 milligram per deciliter to 200 milligram per deciliter. Above this, there's a problem. Not really a problem, but it's not normal. And below this is also not normal. How about birth weight? Those of you in the nursing field knows that the average birth weight is 6 pounds to 9 pounds. So if it's less than 6 pounds, the baby is underweight. If above 9 pounds, the baby is overweight. So, and so on and so forth. There are many examples of this, so many examples of this. With this, I think you have an idea what I'm talking about by now. So let's quickly discuss the properties of a normal distribution. First property is this. A normal distribution is bell-shaped. It's bell-shaped. As you can see here, it is shaped like a bell. It says the mean, median, mode are equal and are located at the center of the distribution. This is where the mean, median, and mode are located. You can see here mean equals median equals mode at the center of the distribution. Another thing is that a normal distribution is unimodal. See, it has only one peak, only one mode. Yeah. Now, the curve is symmetric about the mean. Symmetric is the same. What you have in the left side is same as what you have in the right side. So basically, you can fold these two sides together to one. Okay. The curve is continuous. That is, there's no gaps. Yep, no gaps. Keep continuous. No gap. It doesn't touch the x-axis. See? Now, the curve never touches the x-axis. Never. If you get closer to it, but never touch it. See, this is the x-axis here. You can never touch it. You keep getting close. So you say that it has asymptotic tail. Then total area of the normal curve is equal to 1 or 100%. So for this curve, half of this is 1%. Total area equals, so half of this is 5.5. The other half is 0.5. 0.5 plus 0.5 equals, okay, equals 1, which is, I can call it 100%. So these are properties. Now we can see how to calculate the areas in the normal curve. This is where we use that formula I told, that table, I will be using it a lot. Calculating the area under the normal curve. Now, please, in the table, let me upload something for you. This thing, I'm going to upload it for you in your class, the files. It is called a procedure table. So let me upload it because we'll be using it now to calculate some of the areas under the normal curve. Let me see if you are. I don't think I opened their class. Show more. Okay, I think I have it. So I'm going to upload this for you in the class. Procedure table. Okay. I'll refresh it. So fine. So if you have the chance later today, you can download it. We'll be using this together with the table. Now, for normal distribution, there are two tables we use. One of them is cumulative. The other one is not. If you know how to use both, the cumulative type, you still get the same result. But I encourage you to use the one we'll be using the class, because that's the one. If you know how to use it, you won't get confused. I guess what I'm trying to say is to stick to the one we're using the class so that you won't get confused. So I'm uploading this now for you. So you'll see it in your, excuse me. So it's now procedure table. It's right here now. You can see it right here. So you can print it out too and keep it handy together with the table that we used earlier today. Now, if you have printed the table, like I said, go to table number 5. Let's see. What is it? What is it? What is it? But I hope I do not close it. The table. I think I need to close something so that we have more room. Yeah, where come on, don't see it. Okay. So if you go to table 5, this is table 5. This is the one we're using now. Normal distribution. So now, with this, we can find the area. I think I'm going to close the Excel so we have more room. Let me close the Excel. All right. Let's see. So now let's see how to find the area under the standard normal curve. Let's start with this one. It says calculate the areas under the standard normal curve. Find the area under the standard normal curve which lies to the left of Z 1.76. I'm going to make it okay. And make it bigger. Can you see my screen?
Yes.
So let's find it. Find the area. Let's do part A. Part A. I'll move this down so we have more room. First thing you do is to draw the chart. Solution. Draw the chart for this. To the left of Z 1.76. So we're gonna draw this chart. Okay. I think I'm gonna use this. Okay. And then I'm gonna put the x-axis. Then I'll put the center for the mean. Okay, so Z 1.76. 1.76 should be, can I move this? Okay, thank God it can move. The diagram is a little bit, we are doing it on paper, it's easier. That's the problem here. Okay, good. Now, the center is 0. Yeah, I say 1.76. So the area will be, I say, see, left side is negative, right side is positive. Now, let's see, 1.76. We share the portion that represents 1.7. This is portion that represents 1.76. So we're gonna share it. Okay. All right. Once you get a chart right, you can be able to answer the questions. All right. One more. Oh, actually, two more. I'm going to share all of them. Okay. So now, once you have it, you're looking for the, say, remember, find the area under the standard normal curve to the, oh, it's to the left. I'm sharing the right side. Oh, sorry about that, say to the left. This shading, I have put the shadings wrong. Okay, so what I'm gonna do is to remove these shadings. Remove this. Remove this. Remove it. Remove all of them. All right. So to the left of, see, this is left is on this side. So this is 1.76 to the left. That means I'm going to shed the left side, not the right side. Let me get 1.76 first. Okay. And to the left of it is all these things at the left. So I'm gonna use shed the left side. Okay. All the left sides we shaded. Okay. Left will be shaded. On the left side, we shaded. The shading part is easier if you are doing it on the board. On computer, it's a little bit challenging. So you shaded all the left side. Now, remember this half of this is 0.5, the other half. So now, two more shading to finish the shading on the left side. Okay. Now, you can see from here, from this line, which represents, this line represents 1.76, on the left is shaded. Now, next thing to do is we're looking for the area. The area equals, now look at the procedure table for a shape that looks like this one. If you go to the procedure table, and this is the procedure table right here. What is it? Procedure table. I opened it. It's together with this one. So let's see. Okay, so give me 1 minute. I'll open it now. I think I'm going to close some pages because they're all taking up this whole space. Let me close some pages. Taking the whole space. Okay. Now I can still not see the procedure table. It's right here. Okay, let me put it right there. See, it's right there. You can see that this shape here looks like the one we just drew. This one looks like the one we just drew. The one we just drew is here. See? From here, from this spot, all the way to the left, because it says to the left of Z 1.76. And what, if you look at the procedure table, this is the one that looks like that here. And what did it say? To the left of Z, any Z value, where Z is greater than mean, look at the Z value to get the area, add 0.5 to the area. So we look for the Z value to get the area. And then we add 0.5 to the area. So let's look at the Z value to get the area. So I recommend that you use this table for this class so that you don't get confused. So this is the V value here. and it is 1.76, I believe. We're looking for 1.76. Okay, good. Here is 1.76. This is the Z. This is 1.7 right here. And it go under 6. So 1.7 under 6 is, see 1.7 under 6, 0.4608. See, under 6, 0.4608. Yeah. 0.4608. And the procedure table says to add 0.5 to it. It says add 0.5 to it. Look at the Z value to get the area, say add 0.5 to it. You can see it right here, say add 0.5 to it, to the area. So we're going to add 0.5 to that. Plus 0.5000. If you add them together, the answer you get will be, you can double check with a calculator, 0.98, sorry, 9608. Or if you like, I can call it 96.08%. Any question to this? Any question? Hello?
Hello, sir. Please, can you go up a little bit? I need to.
Consider how this one is a little bit challenging. So I recommend that you use the same table so that you don't get confused. There are two types of tables. There's one that is cumulative. We don't use that one, but if you know how to use that one, the answer will still be good. Otherwise, you can use this one so that and follow the procedure table, and you will not have any problem. Any question to this?
Sorry, where did we get the 0.5 from? I know from the table we got the 0.4608 plus 0.5, 0.5. Where is that from?
The table says add 0.5. Procedure table, you can see from that procedure table right here. Say, you look at the diagram that looks exactly like the one you drew. Say add 0.5.
Okay.
Area.
Okay,
Also,
we use this together with the Z table together.
Yes.
Okay.
Yeah, you get the area from the table, then you followed the instruction from the procedure table.
Okay.
Now, also you can see from here, half of this is 0.5, half of this, right?
Mm-hmm.
This from here to 1.7 is what you saw on the table. That is the 0.4608. Then this other half is 0.5. So together, add them together, that give you the area. Okay?
All right.
So that's basically what we do here. Nice. This one says to the right of Z, the area to the right of Z, 1.76. In that case, again, you have to draw the line. Okay. Draw the charts. I'm not too good at drawing, but at least I think we get the point. Then you draw it. Now 1.76 is positive. That's why it's on the right side, but it says to the right of it now. Put a center. Always put a center. Which is 0. Then this is a 0. You can see this, right? 1.76. You can see this, right? Am I right?
Yes.
Now, it said, let's put the 1.76. Okay. 1.76. Now, this time around, you said to the right. This other one is, you put 1.76, but you go to the left of it because it says to the left. But this time you say to the right. So that means you're going to share the right side. You shared it. Okay. Okay. Right. So now the area you're looking for now becomes the area equals now look for 1.76 from the table. Now look at your procedure table for the one that looks like that. Whenever it is in this form, whenever it is in this form, we call it the tail. This is the tail right here. Call it the tail. This is it's on the tail. See, it's the tail. So now with this, we can look at the procedure tables to see the instruction. See, this one look like the tail. See, this look like this one. What we just drew now look like this one is on the right tail. In any tail, look up the Z value to get the area, subtract the area from 0.5. That's the instruction. So to find the area, we're gonna subtract whatever answer we have. So we're gonna do 0.5 minus whatever area we see for this. Now we can look for it on the table. I'm looking for the table. Let's see. Then look for the table. And this is the table right here. 1.76, 1.76 Z, 1.7, and you gotta go under 6. So 1.7, 0.4608. 0.4608. 0.4608. You subtract this, and that will give you the answer, the area we are looking for. I'm gonna write it down. 0.4608. So from using the calculator, we can get this the subtraction. You have 0.5000 minus 0.4608. 0.0392. 0.0392. 0.0392, or I can call it 3.92%. Again, I keep saying it, please stick to this table. Except if you know how to use the other table very well, then you can use that. The answer will still be the same. But otherwise, stick to this table so that you don't get confused. Print that table, print it out and hold it when you're doing homework. Because next week, the next homework will have this example, this one I'm doing tonight, and the one I'll do tomorrow. Question on this? Any question? Excellent. Now, part C says, again, you draw the line solution. Yeah, I'm moving it. Let me move it down. Okay. Move it to this section until I can draw the chart. So I will best thing to put the numbers in. That's to make it easy for us. One is negative, and the other one is positive. So I'm going to put them here. Negative 0.87. Okay. 0, 1.28. So easy for us to draw the graph. Maybe make it big. Maybe 14. Then I can draw. Okay, so have a shape of 10 minutes left. Okay. So then we have this. Then have the 0 here. Then this one, we move. Okay, 0. Then we can insert the middle part of it. Then for negative 1.8, for negative 0.87, have it right here. And then the other one, 1.28, I have it right here. And you see between them. I got between them right here, share between them. Okay. So when it's like this, all you have to do is to find the areas and add them. So the required area here becomes, find these two, 0.87. I go to the table, 0.87, negative 0.87. This is symmetric. So what is negative, don't worry about the negatives. Negative is just to show you that it's on the left side, that's all. So 0.87, 0.8, you go under 7. I see it's 7 right there. 8 is 0.3080, 0.3078, 0.3078. Okay. The other number is, we have 1.28. You look for it. 1.28. See 1.2. You go under 8. You can see 8 right there. You can see 1.2. You go under 8. 0.3997. 0.3997. Okay. Okay, now go and put it there. 0.39. So that means between the two numbers, I mean between these two values, whenever it's like this, you draw the chart, what you're gonna do is find the areas and add them. So for this one, we got 0.3078 plus for 1.28, we got from the table 0.3997, and that will give you the required area you're looking for. So from the calculator, we have that, okay, 0.3078, 0.3078 plus 0.3997, 0.3997, give me 0.7075, 0.7075. So we go there and put the area. 0.7075. 0.7075. Okay. Any question on this? Any question?
So, Professor, are we not going to use the procedure table?
You can use it. I've shown you how to use it, so you can use it. I put it there for you to use. If you draw this chart, you go there and check it and follow it. If you are confused, so that's why I did the first two examples to show you how to use it. Me, I don't need to use it because I know it already. So that's why I just showed it. If you draw it in this form, and if they look like this, all you have to do is to find these two areas and add them. If you go to the procedure table, to tell you the same thing. Okay.
Okay.
Mm-hmm. So any other question? So tomorrow we begin from here. Normal distribution as say.
Bring it back down, sir.
Professor, you have a class tomorrow?
Yes, I have class tomorrow.
Oh, boy.
Sorry about that, but this is winter class.
But let's finish on time. Tomorrow.
I will finish on time tomorrow. I will finish on time. Yeah, it's not from me, it's from you. I can finish it, but you guys need to understand it. So finishing on time is you. If you understand it quicker, you finish quicker. Okay.
Professor, can I ask a question before you dismiss us? I am having a problem with opening up test 1 and the homework 4. It's not opening.
I think it's because it's past. No, it's not. It's not past due. Are you talking about test 4? Test 1?
Test 1 and the homework. Let me see. I'm trying to pull it back up. The homework for
hold on, Miss. Hold on. Please send me a message, an email.
Okay.
Well, yeah, send me an email. All of you. I'm talking to all of you because we don't have enough time left. Send me an email now. Send an email now to me, to my email, so that I can get your attendance from there. Because if I want to count your attendance now, I won't be able to finish before we're timed out. Yeah.
Thank you. I will.
As a matter of fact, let me take the photo. Don't worry about the email. Hold on, you in particular, send me the email. But the other class member, don't worry. Let me take a picture of these names so I can know who comes here and who are not here. We'll be timed out in a few minutes.
Okay.
So send me an email about this, okay? And then
yes, I will.
I'll look at it.
Thank you.
You're welcome. Please don't go yet. Let me take a photo so I can get your attendance. I'm taking a photo of the names here.
Professor.
Yes, ma'am.
What about the question I asked you about the question for the mean variance and standard deviation?
Which of them is that?
The one we had before we timed out.
Okay. I don't know if it will be able to if the time, but you know what? How about if I put the video?
Yes, Professor, don't forget to post the video.
You can go because I don't know if I'll be able to get it now before we are timed out. How about if I put the video, post the video in the canvas so that you can watch that video is there. Okay?
Okay, Professor.
I have these names here. I have all the names. Okay. Castillo. Everybody have your people. I have the names. I can be able to make sure that I have everybody that came today. All right. I think we have less than a minute. I'm going to put this video so that we can you can get all that information you want from there. So I see you guys tomorrow.
Okay, Professor. Thank you.
Well, I got all your names now.
Thank you, Professor. Good night.
Good night. Yeah.
Good night.
Good night. So don't forget to send me the email about that test, okay?
Yeah. Yes, I am sending it now.
And what's your name again?
Lovelace.
Lovelace. Okay. Okay. I'll be expecting it.
All righty. Thank you.